Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. It's me, Dr. Mansoor Khan, Assistant Professor, Department of Chemistry, Kohat University of Science and Technology. Today I am going to deliver my third lecture, which is based on precision and accuracy. This slide shows the outline of today's lecture, which will cover precision and accuracy, ways of expression of accuracy, ways of expression of precision. Today we will discuss about all these outlines. The first one is accuracy. Accuracy can be defined as it is the closeness of the measurement to true or accepted value. Means if you are performing experiment in the laboratory and you obtain measurements, you obtain some result, then the measurement or the results are then compared with the accepted value. Now the closeness between the accepted or true value is called accuracy. While on the other side, precision can be defined as that how closely repeated measurement approach one another. As we know that the scientific experiment consists of more than one measurement. So all the measurements how closely related with each other, this is called precision. Now the first one is ways of expression accuracy, or we simply can say measurement of accuracy. We will discuss that how accuracy can be measured. It will explain that how the two results are compared based on accuracy. So there are various ways and unit used for measurement of accuracy. The two important tools which are used for measurement of accuracy are absolute error and relative error. These two parameters are used for measurement, or we can say expression of accuracy. Now the first one is absolute error. Absolute error can be defined as the difference between observed value and true or accepted value. If you know the true value of some results of some samples, and when you obtain results during performing experiment, then the difference between the two is called absolute error. Mathematically, absolute error is equal to O minus A. O stands for observed value, while A stands for accepted value. So absolute error is the difference between observed value and accepted value. The second one is relative error. Relative error can be defined as the ratio of the absolute error to the true value. It is often expressed in percent. Relative error is basically when we divide the absolute error with the help by true value, then multiplied by 100 or multiplied by 1000, then we obtain relative error. Mathematically, relative error is equal to absolute error divided by accepted value multiplied by 1000. O stands for observed value and A stands for accepted. This slide shows an example which will explain both absolute and relative error. The statement of an example is, if a 2.62 gram sample is analyzed to be 2.52, then determine absolute and relative error. It means that 2.62 is the accepted value or true value, while 2.52 is observed value or measured value. Now, how we can determine absolute or relative error? Solution. As we know that absolute error is equal to the difference between observed value and true value. So putting the value, as we know that observed value is equal to 2.52 minus accepted value, which is 2.62, and the result is minus 0.10 gram. While on the other hand, the relative error is equal to absolute error divided by accepted value multiplied by 100. So we obtained the value of relative error, which is equal to minus 3.81%. Here is an important note. Negative sign shows that the error is low as compared to the actual value. Here this slide shows some of the importance of accuracy. In scientific measurement, we often dealing with relative error. It means that relative error is often used for measurement of accuracy. We cannot use absolute error for the measurement of accuracy during scientific measurements. Absolute error cannot use in scientific measurement. 1 per 100 or 10 parts per 1000 is often used for measurement of accuracy. In very accurate work, we usually dealing with 1% of relative error. It means that 1% of relative error is acceptable in scientific work. This is an example to explain more about accuracy. The statement of example is, the result of an analysis is 36.97 gram compared with the accepted value of 37.06 gram. Now, what is the relative error in part per 1000? Now, solution is, as we know that before calculating relative error, we should determine absolute error. So the absolute error is equal to observed value minus accepted value. Observed value is 37.97, while the accepted value is 37.06, and the absolute error is minus 0.09. The relative error, we know that it is equal to the absolute error divided by accepted value multiplied by 1000, as we want to determine the relative error in parts per 1000. Therefore, putting the values, we obtained the value of relative error as minus 2.4. The second part of this topic is ways of expression of precision, or it is also called measurement of spread. So there are three statistical parameters which are used for measurement of precision or measurement of spread. The first one is range, second one is variance, and the third one is standard deviation. Now the first one is range. Range can be defined as the difference between highest and lowest measurement in the data set. During measurements, we obtained a data set which consists of large number of measurements. Now, if we calculate the difference between the highest measurement and lowest measurement, then it will be called range. So greater is the range, smaller will be the precision of the work. Or in other words, precision and range are inversely related with each other. It can be obtained by subtracting the smallest value from the largest value present in the data set. The simplest it is, range is the crudest and the most simplest measurement of variation. It is very simple but less important. It gives overall variation and cannot give the individual variation, and it is represented by R. This slide shows an example of range, that how range can be calculated and how range can be used for measurement of precision. So the statement of an example is, during the experiment, the two group students obtained the following measurement. So we have two group students data. Group A student has measurement of 10, 12, 15, 17, 25, 26, 28, 30 and 35. The group B student data consists of 15, 16, 16, 17, 17, 23, 25, 26 and 30. Now we know that range is the difference between the highest value and the lowest value present in the data set. For group A, the highest value is 35 and the lowest value is 25. Here HR is used for highest reading and LR is used for lowest reading. Now range is the difference between highest reading minus lowest reading. So the highest reading is 35 and the lowest reading is 10 for group A. So the value of range for group A is 25. While on the other hand, the range value for group of student B is 15. Now what we can conclude from this example? It can be concluded from the example that the group B data is the student of group B is the data of student of group B is more precise as compared to the data of student of group A, because the range value of group B student is 15, which is less as compared to 25 to that of range of group A student. It means that the work student of group B is more precise with smaller value of range 15 as compared with group A student having range 25. Now this slide shows some properties of range. It is one of the statistical parameter which is used to measure the accuracy. It only gives overall spread and unable to measure the individual deviation. It is one of the limitation of the range. For example, this limitation can be explained by using the following example. For example, we have two different data sets, A and B. A and B both consist of different reading, but they are smaller and the highest value are same, so the range for both the data is the same. Otherwise, it is clearly shows that the two data set is completely different from each other. So it is one of the drawback of range. The second parameter which is used for measurement of precision or measurement of spread is variance. It is very important. It can be defined as the square of the standard deviation is called variance. When you calculate standard deviation, when you take the square of the standard deviation, then it is called variance. What is standard deviation? We will discuss it in the coming slides. One of the most important measures of variation. It shows variation at the mean. It is represented by S square value. Mathematically, range variance is equal to sigma xi minus x whole square divided by n minus n. This slide shows step to calculate variance. The first step is calculate mean of the data set. The second step, calculate the difference between each score and mean. The third step is square the difference between each score and mean. The fourth step is add up all the square of the difference between and mean. Add up all the square of the difference between each score and mean. Divided the obtained sum by n minus n. This slide shows an example to calculate variance. Suppose that we have two group data. Group A consists of 35, 35, 35, 35, 35, 35. While the difference between each measured value and the mean value of group A is 35, while the difference between each value and mean is equal to 0, and the square of the difference between each measurement and mean is also equal to 0. So summation xi minus x whole square is also equal to 0, while group B consists of 73, 11, 49, 35, 15, 27. The mean value is also equal to 35. The difference between individual measurement and mean is equal to 38, minus 24, 14, 0, minus 20 and 8. While the square of the mean while the square of the difference of the individual measurement to the mean is equal to 1,444, 576, 196, 0, 464. while the summation xi minus x whole square is equal to 2680. Now the variance for group A is equal to 0 divided by 6 minus 1, which is equal to 0, while the variance for group B is equal to 538. Now what is the conclusion? What we conclude from this example? From this example we conclude that the variance of group A is equal to 0, which is minimum, while the variance of group B is 538. So the variance of group A is less as compared to the variance of group B. So the work performed by group A is more precise as compared to the work performed by group B. The third and the most important one is standard deviation. So standard deviation is square root of variance is called standard deviation. It is the most important measure of variation. It is the average distance that deviates from the mean value. It is denoted by S. Mathematically, it is equal to summation xi divided by x whole to n divided by n minus 1 whole square. Step used for calculating standard deviation: solve the mean value, subtract the mean value for each score, square the difference between each score and mean, add up all square of the difference between each score and mean, divided the obtained by n minus 1, and the last one is take square root of the answer. There is no need of an example for standard deviation because standard deviation and variance has the same example and the same conclusion can come from the example. Thank you for joining us.